Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss integrals. In this chapter, we are going to discuss the sums in the exercise 7.5, page number 322 in the textbook. Okay, my children. In the previous class, we have discussed type 1 and type 2 sums in integrating a function by partial fractions method, integrating a rational function by using partial fractions method. There are only three types of sums in these rational functions. By using partial fractions method, there are only three types of sums are there. In the previous class we have discussed two types of sums. I hope you have learnt well. You understood that two types of sums. Okay, my children. Now come to the third type of sums. The denominator contains irreducible quadratic factors. Okay, my children. This is third type. Okay, my children. Listen these third type of sums carefully, my children. Integrating a rational function by using partial fractions method. Okay, my children. Right. Are you ready to listen the class, my children? Right. Come to the question number 13. From question number 7 to question number 12, all the sums comes under type 2 only. Okay, my children. Please try the questions from question number 6 to question number 12. Now from the question number 13, see, integrate 2 by 1 minus x into 1 plus x square. Okay, my children. Understood? Right. We have to integrate this function. Now let us assume that capital letter I is equal to integral 2 by 1 minus x into 1 plus x square dx. We assumed here the given integral 2 by 1 minus x into 1 plus x square dx is equal to capital letter I. Okay, my children, understood this step. Now what is integrand here? This 2 by 1 minus x into 1 plus x square. If you observe, this is a polynomial. Here numerator is 2. Just I am writing in the short form. Numerator 2, that is p of x. P of x is equal to 2, and denominator q of x is equal to 1 minus x into 1 plus x square. Its degree of this polynomial is 0. Now come to this degree of this polynomial. What is the degree of this polynomial? 3. Okay, my children, do you know how to find the degree of the polynomial? Here x power 1, here x square. We are multiplying, so we are adding the exponents of x, powers of x, 1 plus 2, 3. So degree of this denominator is 3. So it is a proper rational function. So we can use partial fractions method. First we have to check whether the given rational function is a proper rational function or not. Okay, my children, only for proper rational functions we use partial fractions method. Okay, my children, right. Here p of x by q of x is a proper rational function. This integrand is a proper rational function. So we write partial fractions. Okay, my children. So let 2 by 1 minus x into 1 plus x square is equal to. Now come to the denominator, my children. We have to focus on the denominator. How many factors are there? 2 factors. 1 minus x is one factor. 1 plus x square is another factor. Okay, my dear children, understood this point? Right. This is 1 minus x. First term is a linear, non-repeated linear factor. So, corresponding to this non-repeated linear factor, we can write a partial fraction like this: 1 by a by 1 minus x. Do you remember that point, my dear children? For every non-repeated linear factor corresponding to every non-linear, non-repeated linear factor, we write like this: constant, some number, some letter a by 1 minus x. Okay, my children, understood. Now come to the second factor, 1 plus x square. It is a quadratic expression, but here we can't write the factors of this quadratic expression. That is why it is called irreducible quadratic factor. This is irreducible quadratic expression. Okay, my children, understood this meaning of this word? Irreducible means here we cannot write the factors of this quadratic expression. That is the meaning of irreducible quadratic factor. Okay, my children. So for this quadratic, irreducible quadratic linear factor corresponding to this irreducible quadratic factor, we write a partial fraction like this: bx plus c by 1 plus x square. Okay, my children, understood this partial fraction corresponding to this irreducible quadratic expression, we are writing this partial fraction. Okay, my children, understood? Right. This part is very important. Writing the partial fractions to a proper rational function. This is the important step. Okay, my children. Now, hereafter we follow the previous steps, previous method. How to find a value, b value. We have to take a LCM. Okay, my children. This implies 2 by 1 minus x into 1 plus x square is equal to, here we let us take LCM of these two numbers. For 1 minus x into 1 plus x square, LCM is 1 minus x into 1 plus x square. Okay, my children, understood this LCM? Right. A into 1 minus x gets cancelled. Then what will you get? 1 plus x square. Okay, my children, understood this term? Right. Plus bx plus c into bx plus c into, here 1 plus x square gets cancelled. What will be left here? 1 minus x. 1 minus x. Okay, my children, understood this part? Right. Then we strike out the denominators. We can strike out the denominators. Okay, my children? Right. This implies 2 is equal to, what you get in RHS? A into 1 plus x square plus bx plus c into 1 minus x square. Let us consider this is equation 2. Let us consider this is equation 2. 1 minus x, not 1 minus x square. 1 minus x. Okay, 1 plus x square, 1 plus x square gets cancelled. We get 1 minus x only. Okay, 1 minus x. Okay, my teacher understood this second equation. Right. Now, to find a, b, c, we had to find the values of a, b and c. First of all, we had to choose the non-repeated linear factor in the given rational function in the denominator. What is the first non-repeated linear factor in this rational function? 1 minus x. So in rough work, I told you that part. In rough work, take the non-repeated linear factor in the denominator. This is non-repeated linear factor. So we write 1 minus x is equal to 0. Okay, my children, understood this equation? From this equation, we had to find the value of x. So we got the value of x here. Now we have to substitute this value of x in this equation 2. Okay, my children? Right. Put x is equal to 2. Sorry, put x is equal to 1. in the equation 1, in the equation 2. In the equation 2, we have to substitute x is equal to 1. Okay, my children, this implies in LHS no x term is there, so we write this term number as it is. A into 1 plus here x square is there, so 1 whole square. Okay, my children, understood this part? Right. Plus bx is there, b into 1 plus c into 1 minus 1. Understood this step, my children? In this equation 2, we are substituting x is equal to 0. Then we get this step. Okay, my children, understood? Right. This implies 2 is equal to a into here in this brackets, what will get 1 plus 1 square. 1 square value is 1. So 1 plus 1, 2. 2 into a, to a. Okay, my children, understood this one? Now come to the second term. Here 1 minus 1 is 0. 1 minus 1 is there. So what is the value of 1 minus 1? 0. So 0 into any number, we get 0 only. So we get second term is 0. So I am not writing second term. Understood this point, my children? Right. This implies here 2 gets cancelled. A is equal to 1. We got the value of a. Okay, my children, understood this one? Right. So we got the value of a, that is a is equal to 1. Now we have to find b and c values. To find the values of b and c, here non-repeated linear factors are not there in the denominator. Only one non-repeated linear factor is given. With the help of non-repeated linear factor, we wrote the equation in rough work. Okay, my children, do you remember that part? We found the value of x and we substituted the value of x in the equation 1. Then we got in this equation we substituted, then we got a value. But what should we do next? We have to compare the coefficients of x square on both sides. What is the highest power of x in RHS? In RHS or in LHS? Highest power of x square. So comparing the coefficients of x square on both sides. We have to compare the highest power of x, either LHS side or RHS side. We have to take highest power of x coefficients. Okay, my children. What is the highest power x square coefficient here? In LHS, no x square term, so its coefficient is 0. Okay, but still understood this 0, right? Is equal to, come to RHS. What is the coefficient of x square? Ax square, isn't it or not, my children? So what do you get? A. Okay, my children, understood this one? I am writing directly x square coefficient from this equation 2. Now, from these factors, bx into minus x, what will get? Minus bx square, isn't it or not? Yes. So minus b is a coefficient of x square. Okay, my children, understood? Otherwise, you have to expand. We have to expand this one by distributive property. You have to expand. Here also use the distributive property and expand. Then write this step. Okay, my children, if you are getting any confusion here after, what will you do? Here multiply these two, and here also multiply these two expressions. Then compare the coefficients of x square on both sides. Okay, my children? Right. Then you get a minus b. Then what is a value? 1. 1 minus b. Because a is equal to 1. We have already found the value of a. So we are substituting a value here. So this implies, what will you get? B is equal to 1. So the value of b is also 1. We got b value. Now we have to get c value. To get the value of c, we have to compare the coefficients of x. After x square, what is the least x coefficient of x only? Isn't it or not, my children? Least exponent of x after x square. What is that one? X. So comparing the coefficients of x on both sides. After x square, we have to compare x coefficients. After x, if you want to find out some more values, we have to equate coefficients of comparing the constants. After x square, x. After x term, we have to compare constant terms. Okay, my children. In this order, we have to compare the terms on both sides. Okay, my children. Right. This implies here coefficient of x is 0 because x term is not there in LHS. Now come to this RHS. Here we don't get here x term. So we leave this term. Here we get x term. Bx into 1. What will you get? B. Isn't it or not, my children? B. C into minus x. Minus cx. We get minus cx. So coefficient of x is minus c. Understood this? B minus c, my children? Right. We got already b value. We see b is equal to 1. So 0, 1 minus c, because b is equal to 1. The value of b is equal to 1. We have already found it. This implies c is equal to 1. Okay, my children, we got a value 1, b value also 1, c value is also 1. Now we substitute these three values in the equation 1. Then what we get? Substitute a is equal to 1, b is equal to 1, and c is equal to 1 in the equation 1. In the equation 1, we get 2 by 1 minus x into 1 plus x square. This is the equation 2, equation 1, LHS part. A by, that means 1 by 1 minus x plus bx plus c. B means 1. 1 into x plus c means 1 by 1 plus x square. Understood this step, my children? We substituted a is equal to 1, b is equal to 1, and c is equal to 1. In the equation 1, we get this one. Okay, my children, understood? Right. This implies 2 by 1 minus x into 1 plus x square is equal to 1 by 1 minus x plus 1 by 1 plus x square. Okay, my children, understood this step? Just we simplified this term and we wrote it. Now let us split into two fractions. This also we should let us split into two fractions. So 2 by 1 minus x into 1 plus x square is equal to 1 by 1 minus x plus x by 1 plus x square plus 1 by 1 plus x square. I splitted this fraction into two fractions. Then x by 1 plus x square plus 1 by 1 plus x square. Then we got three terms. Okay, my children, understood this one? Right. The previous step, we have taken integration on both sides. Then we get integral 2 by 1 minus x into 1 plus x square dx is equal to. In RHS, I am taking integration separately for every term. So integral 1 by 1 minus x dx plus integral x by 1 plus x square dx plus integral 1 by 1 plus x square dx. We got three integrals. Okay, my children? Right. So this implies this is assumed as capital letter I is equal to, let us assume that this is I1 plus this is I2, second integration is I2, and plus I3. Let us assume this is equation 3. Let us find the integrals of each and every one separately. Where I1 is equal to integral dx by 1 minus x, I2 is equal to integral x by 1 plus x square dx, and I3 is equal to integral 1 by 1 plus x square dx. Okay, my children. So let us find the I1, I2, I3 values separately. Therefore, I1 is equal to integral 1 by 1 minus x dx. If you observe this integrand, it is in the form of integral 1 by ax plus b dx. Integral 1 by ax plus b dx. Then what is the integration 1 by a, that means 1 by x quotient here minus 1 into log mod ax plus b, that is that function as it is. Okay, my children, because integral 1 by ax plus b dx is equal to 1 by a log mod ax plus b. By using this integral, we wrote this step. Understood this step, my children? Right. This is equal to minus log mod 1 minus x. Okay, my children, understood this one? So we got I1 value. Okay, my children, now come to I2. I2 is equal to integral x by 1 plus x square dx. Okay, my children. So here we use integration by substitution method. Okay, my children. 1 plus x square. Put 1 plus x square. 1 plus x square is equal to, let us consider t. Then differentiating with respect to x, with respect to t. Then what is derivative of x here? 1, 0. Plus what is derivative of x square? 2x into dx by dt is equal to 1. Do you remember these steps, my children? Integration by substitution method. To find the value of I2 here, we are using integration by substitution method. So what is the function in the denominator? 1 plus x square. So we are taking 1 plus x square is equal to t. Differentiating with respect to t. Then derivative of 1 is 0. Plus it is d by dx of x power n formula 2x. Its derivative is 2x into dx by dt is equal to its derivative is 1. Okay, my children, understood this one? Right. This implies what we get? 2x dx by dt is equal to 1. From this equation, let us find x dx value. X dx is equal to dt by 2. Okay, my children, here 2 by dt is there. It's reciprocal. We wrote it's reciprocal. Then we get this step. Understood this step, my children? Right. Therefore, I2 is equal to integral x dx is 1 dt by 2. So 1 by 2 I am writing outside numerical coefficient. Dt by 1 plus x square is taken as t. Understood this step, my children? Right. That is equal to 1 by 2 into log mod t, because integral 1 by x dx is equal to log mod x. Okay, my children, to find the value of I2, we are using substitution method, integration by substitution method. Okay, my children, that is equal to 1 by 2 log mod 1 plus x square. Here again we are writing the t value in terms of x. So 1 plus x square. We got I2 value also. Okay, my children, understood? So we have to find I3 also. Okay, my children? Right. Find the value of I3. I3 is equal to integral 1 by 1 plus x square dx. Integral 1 by 1 plus x square dx. This is a standard integral into 1 by 1 plus x square tan inverse x. Okay, my children, because integral 1 by 1 plus x square dx is equal to tan inverse x. I gave the standard integral formula. Okay, my children. So we found I3 value also. Okay, my children. Therefore, I is equal to I1 plus I2 plus I3. What is I1? Minus log mod 1 minus x. What is I2? 1 by 2 log mod 1 plus x square plus what is I3? Plus tan inverse x. So this is the last step. So at last step, what should we do? We have to add a constant of integration. Okay, my children, this is the type 3 sum. In this type 3 sum, integrating a rational function. Okay, my children, integrating a rational function when the denominator contains irreducible quadratic expression. This is a third type. Okay, my children, understood? Right. Now come to the next question, my children. Question number 14. Integrate 3x minus 1 by x plus 2 whole square. Understood this question, my children? Right. Come to the solution part. Let I is equal to integral 3x minus 1 by x plus 2 whole square dx. We assumed here capital letter I is equal to integral 3x minus 1 by x plus 2 whole square dx. Understood this step, my children? Right. Here numerator is a polynomial in x and denominator is also polynomial in x. So it is a rational function. Okay, my children. So let us find the degree of this numerator. Numerator nr short form. Okay, my children. Don't be confused here. nr stands for numerator. P of x is equal to 3x minus 1. Its degree is 1. Highest power of x 1. Understood this step, my children? Right. Come to the denominator. Dr stands for denominator. Okay, my children. Q of x. What is Q of x? Expressed to whole square. What is its degree? 2. Highest power of x. If you expand this one, we get a quadratic expression. So, its highest power of x is 2. Okay, my children, understood? So, degree of P of x is less than degree of Q of x. Therefore, P of x by Q of x is a proper rational function. Only for proper rational functions we can write partial fractions. Okay, my children? Right. Now, let us consider 3x minus 1 by x plus 2 whole square is equal to. Now we are going to write partial fractions. Then come to the denominator. We have to focus on the denominator while you are writing partial fractions. How many factors are there? Only one factor, x plus 1, but it is repeated 2 times. Whole square means 2 times. So this is a linear factor but repeated. So it is a repeated linear factor, means this is type 2 sum. Okay, my children, understood this point? This is a repeated linear factor. So corresponding to this repeated linear factor, we have to write two partial fractions, that is a by x plus 2, that is one partial fraction, plus b by x plus 2 whole square. Because this repeated linear factor is repeating 2 times. Okay, medicine. That is why we are writing two partial fractions corresponding to this repeated linear factor. We are writing like this. Understood this step, medicine? Right. Let us consider this is equation 1. Let us assume that that is equation 1. So in this equation, we have to find the values of a and b. What should we do? We have to take LCM of these denominators. Okay, my children. This implies 3x minus 1 whole divided by x plus 2 whole square is equal to, for these two numbers, LCM is x plus 2 whole square only, not x plus 2 into x plus 2 whole square. Okay, my children. Understood this point? So this is LCM for these two denominators. Then what will you get? A into x plus 2 here one time gets. So x plus 2 times. Okay, but you understood this one. X plus 2 whole square, x plus 2 whole square gets cancelled, B only. Okay, but you understood this one. Right. Now we strike out the denominators. Then what will you get? 3x minus 1 is equal to a into x plus 2 plus b. Let us consider this is equation 2. In this equation 2, we had to find the values of a and b. Okay, my children. So again come to the rational function and the denominator. What is the linear factor here? X plus 2. X plus 2. But it is a repeated linear factor. Okay, my children. So first we take a rough work. In rough work, x plus 2 is equal to 0 because here x plus 2 is a linear factor. So we are writing this equation. Understood this equation, my children? Right. From this equation, we find x value. X is equal to minus 2. So we substitute this x value in this equation 2. Okay, my children? So put x is equal to minus 2 in equation 2. In equation 2, we get 3 into minus 2 minus 1. In LHS, I substituted x is equal to minus 2. Then we get LHS. Understood this LHS, my children? Right, come to RHS. A into minus 2 plus 2 plus b. Here x is there, so I wrote minus 2 plus we wrote the remaining terms as it is. Understood this step, my children? Right. This implies what you will get minus 6 minus 1 is equal to first term. See there, minus 2 plus 2. What will you get? 0. A into 0, 0. So I am not writing this first term. Plus b. So I am writing only second term. Understood this is step, my children? Right. This implies minus 7 is equal to b. Minus 6 minus 1. What will you get? Minus 7. Okay, my children, understood? This implies b is equal to minus 7. We got value of b. But we have to find a value also. But there is only one linear factor that we have written and we found x value. Now we have to compare the coefficients highest power of x, the coefficients of highest power of x on both sides. As we have done for the previous question, after substituting the values of x by taking linear factors, non-repeated linear factors and repeated linear factors, we got this like this. After that, to find the remaining values, we had to compare the coefficients of highest power of x on both sides. Okay, my children, understood this point? Right. In this equation, we compare the coefficients of x. Highest power of x is 1. Here also highest power of x is 1. So let us compare the coefficients of x on both sides. On both sides, we get, what is the coefficient of x here? 3 is equal to, what is the coefficient of x here? A. So this implies a is equal to 3. Okay, my children, we got a value also. Previously we got b is equal to minus 7. So let us substitute a is equal to 3. A is equal to 3 and b is equal to minus 7 in the equation 1. In the equation 1, we get 3x minus 1 by x plus 2 whole square is equal to a by, that means 3 by x plus 2 minus 7 by x plus 2 whole square. We substituted a and b values in the equation 2, then we get in the equation 1 we get this equation. Okay, my children. Now we take integration on both sides. Integrating on both sides. Bs stands for b dot s, both sides. Okay, my children. Right. This implies integral 3x minus 1 by x plus 2 whole square dx is equal to 3 into integral 1 by x plus 2 dx. Here I wrote the numerical coefficient directly before the integral sign. I wrote the remaining function. Okay, my dear children. Similarly, minus 7 into integral 1 by x plus 2 whole square dx. Here also for the second term also I wrote minus 7 numerical coefficient. Before the integral sign I wrote the remaining function. Okay, my children, understood this one? Right. This implies I is equal to, this is considered as capital letter I, is equal to 3 into, it is in the form of integral 1 by ax plus b, linear expression. So log mod x plus 2 minus, this can be written as integral x plus 2 whole power minus 2 dx. Okay, my children, this is written as x plus 2 whole power minus 2. It is taken to LHS in the numerator. It was brought to numerator. Then it become x plus 2 whole power minus 2. For this one, I am writing the formula integral 1 by ax plus b dx is equal to 1 by a log mod ax plus b. 1 by a log mod ax plus b. By using this integral formula, we wrote this first term. Okay, my children, understood? Right. That is equal to 3 log mod x plus 2 minus 7 into, it is in the form of integral linear expression whole power n, ax plus b whole power n. What is the formula? Ax plus b whole power n plus 1 by, so x plus 2 whole power minus 2 plus 1 by minus 2 plus 1. Okay, my children, because integral 1 by ax plus b whole power n dx is equal to 1 by a into ax plus b whole power n plus 1 by n plus 1. By using this integral formula, we wrote this second term. Okay, my children, understood this one? Right. So integration part is over. Let us simplify the term. 3 log mod x plus 2. We get here minus 1. So minus plus. Plus 7 by x plus 2. Because we get x plus 2 whole power minus 1. This can be written as 1 by x plus 2. Okay, my children. Plus c. This is the last step. Direct I am writing plus c. Okay, my children. Understood? Right. Okay, my dear children. Now, please do the remaining sums in this exercise. Okay, my children. Every question will be of either type 1, type 2 or type 3. Any one of these 3 types only. Okay, my dear children. Right. Please try the remaining questions yourself. If you have any doubt, ask your doubts and get your doubts clarified. Okay, my dear children. In the next class, I will explain the next exercise. Okay, my dear children. Right.